There is more than one way to solve an and compound inequality. One way to solve an and compound inequality is to rewrite this compound inequality as its two simple inequalities. So negative 5 is less than 3x minus 8. I'm going to rewrite that as 3x minus 8 is greater than negative 5. So that's this part of the compound inequality. And now we have the right-hand side, 3x minus 8 is less than or equal to 1. So these two statements are equivalent. And so one way to solve this compound inequality is to separately solve these two simple inequalities. I can add 8 to both sides for 3x minus 8 is greater than negative 5. That gives me 3x is greater than 3, or x is greater than 1. Solving the other simple inequality, I have 3x is less than or equal to 9. Dividing both sides by 3, I get x is less than or equal to 3. Since these both must be true, x is greater than 1 and x is less than or equal to 3, the solution to this inequality is 1 is less than x is less than or equal to 3. Not my preferred solution strategy, but if this works for you, that is great. My preferred solution strategy takes into account the fact that if we look at my solution strategy or my solution for both inequalities, I'm adding 8 and then I'm dividing by 3. So I can actually take that piece of information and in one sort of step, I can add 8 to both simple inequalities and then I can divide by 3. What I will do is perform inverse operations to all three sections of the compound inequality. What I'm trying to do here is isolate the x in the middle of the inequality. So inverse operations to isolate the variable in the middle of the inequality. The first thing I'm going to do is add 8 to get rid of the minus 8, the inverse of subtracting 8, adding 8. And I'm going to do that to all three sections of the inequality. That gives me 3 is less than 3x is less than or equal to 9. You can see adding 8 was my first step when I did this by separating out the two inequalities. My next step, divide by 3. That is my next inverse operation in order to isolate x. Undoing the multiplication by 3, I divide by 3. Now I have 1 is less than x is less than or equal to 3. This is a much more straightforward process, I think, much less prone to error than this one. But if you would rather separate it into the two component inequalities, that is fine. Another example here. Again, our goal is to isolate the x into the middle. So we have x in the middle of our compound inequality. X is being multiplied by negative 2, and then we're adding 8. That means I need to subtract 8, not just from the middle, but from all three sections. That gives me negative 6 is less than or equal to 2, negative 2x is less than 12. Final inverse operation, I have to undo the multiplication by negative 2, so I divide by negative 2. When I multiply or divide by a negative, I must flip my inequalities. So I get 3 is greater than or equal to x is greater than negative 6. This is not my final solution. I need to rewrite it. Smallest number on the left, less than sign, x less than or equal to, so this part had the equal to 3. So I'm rewriting my solution so that it has less than sign's smallest number on the left. The reason I do this is I want my solution to line right up with my graph. So when I graph the solution to this compound inequality, it should directly match my solution. Negative 6 is less than x is less than or equal to 3.